Hey everybody, Mr. Barry here. More two-step equation word problems in Algebra 1. We have a cell phone company charges a monthly rate of $12.95 and 25 cents per minute. The total bill for M minutes is $21.20. Which of the following equations represents this situation? So we do have a multiple choice scenario here. B, it looks like we're going to solve the equation for part A and determine how many minutes that you can talk. So a couple things to note here. I want to go ahead and at least, might not be a terrible thing to take note of the different numbers in this problem. $12.95, 25 cents per minute. And I'm going to stop right there and talk about 25 cents because with money, we got to be careful. It's not the number 25. It's 25 cents, which, as we all know, is less than $1. So I want to take a moment here. Sometimes these word problems can be tricky, no doubt about it, but let's actually write down 25 cents like what it would appear in money. So it would be 0.25. That's going to be a huge issue in this problem. Then finally, the total bill for M minutes is $21.20. It did say there that the total, and the word total is a kind of important word. So just to make note of the word total, it says the total bill for M minutes is $21.20. So just so that we're aware, that's why we have $21.20 all by itself on one side of the equation, because $21.20 is the total. So there's no mystery to that. Every single multiple choice question here, or answer, has $21.20 by itself. Now I have to kind of decipher between where would be my word of rate. Where are one of those key terms that we like to talk about in math, specifically solving equations, and I'm talking about the words each, every, and per. So if I read the first sentence again, a cell phone company charges a monthly rate of, and actually it says the word of twice there, how about that? $12.95 and 25 cents per minute. All right, so I can't tell you enough, that word per right there is a huge deal in this problem, because what that word per means is usually after it comes our variable, and after the word per is the word minute, which we know M here stands for the amount of minutes. So it's not really too confusing that the word minute would appear behind the word per, because that's what's going to happen. So we know that 0.25 is the number that's right in front of the word per, the word minutes right after per. So somewhere within our problem, we need to have 0.25 attached to a variable because of the word per there. So I'm looking for the ones that have 0.25 attached to the variable. In this case, it's M. All right, and 0.25 is here, but there's no variable. That's just the number 25, which we said we're not worried about the number 25 because we know that 25 cents is 0.25 and not just 25. And then we have these two here again. It's not the number 25 that we need. It's the number 0.25 because it's 25 cents. So that right there is my equation. Just for the heck of it, $12.95 is a constant. No matter what, it seems as if the cell phone is going to charge that every single month. So even if you didn't make a phone call at all or use your phone at all, you're getting charged $12.95 each month no matter what. Going to solve this equation real quickly. 21.20 is equal to 12.95 plus 0.25 m. Let's isolate that variable, which means that 12.95 is positive. We're going to use that subtraction property of equality. 12.95 minus 12.95 would give me 0.25 m on the side by itself. 21.20 is something that I have to type into a calculator, minus 12.95. Looks like that's 8.25. We use the subtraction property of equality there. 0.25 times m, which means the inverse operation would be to divide. And 8.25 divided by 0.25 would be 33. So we just use our division property of equality. We got 33 is equal to m, meaning